Hello students, this video is brought to you by Southern Pathshala. Now we will solve MCQs on current electricity. SI unit of electric current is ampere, option B. In metal, current is due to the flow of free electrons. Okay, third one, according to Ohm's law, current through a conductor, it is directly proportional to potential difference. That is V is equal to I into R. Therefore directly proportional to the potential difference between the ends of the conductor. Identify one which does not obey Ohm's law. Okay, the devices which does not obey Ohm's law are called as non-ohmic devices. Here the non-ohmic device, it is diode. It's a semiconductor diode. Okay, SI unit of resistance is that is nothing but ohm. Equation which represent Ohm's law is V is equal to I into R. The equation which represent the equivalent form of Ohm's law is that is nothing but J is equal to sigma into E. Okay, that is microscopic Ohm's law. Resistance of a conductor depends on length of the conductor. Nodi, if you V is equal to I into R anta tagoltira, this R is equal to V divided by R. This does not depends on this, does not depend, because R is a proportionality constant. You know that resistance depends on length. Okay, R is proportional to L divided by area. Therefore, here it will be length of the conductor will be the correct answer. Which of the following quantities will decide the resistance of a metal? Okay, resistance of the metal is given by, that is R is equal to rho into L divided by E. Okay, length of the metal, it is correct, area of cross section correct, and temperature. Therefore, all the above is the correct answer. Which of the following quantities will vary the resistivity of the material? Okay, resistivity does not depends on the length. Okay, resistivity does not depend on length and area. Therefore, both options are correct. Correct. Therefore, the correct option is temperature, because resistivity rho is equal to rho naught into 1 plus alpha into delta T. Okay, then select the vector quantity among the following. So you know that current is a scalar quantity, potential difference is scalar quantity, electric charge is a scalar quantity. Therefore, current density, it is given by J is equal to I divided by A. Okay, adana vector formally adana bardre I is equal to vector J cross vector A. Okay, then a cost anta, remember the dot product of J and A, it will be nothing but the current. Therefore, the current density will be the correct answer. Reciprocal of resistance is called as conductance. Okay, and next question, reciprocal of resistivity is called as conductivity. SI unit of conductance, conductance is mho, or it is also, you can write it as Simon. Okay, Simon is also one of the unit. SI unit of resistivity is nothing but ohm meter. SI unit of conductivity is mho per meter, or you can write as Simon per meter. That is also correct one. Current flowing through a conductor per unit cross sectional area normal to the flow is called as current density. Okay, that is I wrote now, that is J is equal to I divided by A. Average velocity of the electron moving under influence of electric field is called as, that is drift velocity. That is given by Vd is equal to E capital E tau divided by M. Okay, negative sign we have to write. Drift velocity acquired by free electron in a conductor per unit electric field is called as mobility. It is denoted by mu is equal to drift velocity divided by electric field. For metals, as temperature increases, the resistivity increases, because I wrote there rho is equal to rho naught into 1 plus alpha into delta T. That is, delta T is temperature. This is the temperature, that is directly proportional. For metals, the temperature increases, their conductivity decreases, because resistivity is inversely proportional to the conductivity. Conductivity will be denoted by G. And resistivity increase agutte andre conductivity enagbeku, decrease aglebeku. Materials used for the preparation of standard resistance must have low temperature coefficient, that is alpha must be low. Alpha ಏನಾಗಿರಬೇಕು, ಚಿಕ್ಕದಾಗಿರಬೇಕು. Manganese and constantine are used in the construction of standard resistance box because their temperature coefficient are very low. Question number 24. Metal strips are used as connecting leads in meter bridge wire. Why? Because meter bridge strips don't contribute any additional resistance since they have large cross section area. Okay, therefore that is a correct answer. Next question, question number 25. SI unit of temperature coefficient is, that is per degree centigrade. Why? Because if you take rho is equal to rho naught into 1 plus alpha t ಅಂತ ತಗೊಂಡ್ರೆ ಇದೇನಾಗುತ್ತೆ, ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಕ್ಯಾನ್ಸಲ್ ಆಗಿಬಿಡುತ್ತೆ. ಅವಾಗ ಏನಾಯ್ತು, ಆಲ್ಫಾ ಈಸ್ ಪ್ರಪೋರ್ಷನಲ್ ಟು 1 ಡಿವೈಡ್ ಬೈ ಡೆಲ್ಟಾ ಟಿ ಆಗುತ್ತೆ. ಅಂದರೆ ಡೆಲ್ಟಾ ಟಿ ಅಂದರೆ ಟೆಂಪ್ರೇಚರ್ಗೆ ಏನಿರುತ್ತೆ, ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಇರುತ್ತೆ. ದರ್ಫೋರ್ ಪರ್ ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ವಿಲ್ ಬಿ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. Average time interval between two successive collision is called as relaxation time. The tolerance value represented for the color band of silver. Okay, silver it is nothing but plus 10. Okay, and it will be for gold and this will be for no color. Okay, no color. Okay, this is ilvaila. The color code sequence for represented for resistance of 39 into 10 to the power of 2R, that is nothing but orange, white and red. In order to minimize power loss during the time transmission, electric power is transmitted at, okay, low current at high voltage. ಯಾಕಂತ ಹೇಳಿದ್ರೆ we have the relation power loss P is equal to power loss, it is P is equal to, it is P square RC divided by, it will be V square ಅಂತ ಬರುತ್ತೆ. ಇದು ನನಗೆ ಪವರ್ ಡ್ಯೂರಿಂಗ್ ದಿ ಟ್ರಾನ್ಸ್ಮಿಷನ್, ಇದು ಪವರ್. ಅವಾಗ ಏನಾಯ್ತು, ವಿ ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ ವಿ ನನಗೆ ಜಾಸ್ತಿ ಬಂತು ಅಂದ್ರೆ ಪವರ್ ಲಾಸ್ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಬಿ ಕಡಿಮೆ. ಅಂದ್ರೆ ಏನಾಗಬೇಕು, ವೋಲ್ಟೇಜ್ ಏನಾಗಿರ್ಬೇಕು, ಹೈ ಇರಬೇಕು. ವೋಲ್ಟೇಜ್ ಆದಾಗ ಲೋ ಕರೆಂಟ್ ಅನ್ನ ನಾವು ಪಾಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಆಪ್ಷನ್ ಡಿ ವಿಲ್ ಬಿ ಕರೆಕ್ಟ್. Two different resistances are connected in series across the battery. Select the correct statement. Okay, series connect ಮಾಡಿದಾಗ V is equal to V1 plus V2 ಆಗಿರುತ್ತೆ. I is equal to same ಇರುತ್ತೆ. Therefore we can write current through both are same ಅಂತ. Two different resistance are connected in parallel across the battery. Select which is correct. That is voltage across both are same. ಯಾಕೆ ಇಲ್ಲಿ current ಡಿವೈಡ್ ಆಗುತ್ತೆ. I is equal to I1 plus I2 ಆಗಿ ಡಿವೈಡ್ ಆಗುತ್ತೆ. Two resistance are connected in series. Equivalent resistance of the combination, that is given by Rs is equal to R1 plus R2. It is always higher than the highest value. Okay. Two resistance, they are connected in parallel. Equivalent resistance is given by, that is Rp is equal to R1 R2 divided by R1 plus R2, which is always lesser than the lowest of the resistance value. Equivalent resistance when two resistance R1 R2 connected in series is R equivalent is equal to R1 plus R2. Okay, so next question number 35. Equivalent resistance when two resistance are connected in parallel, that is R equivalent is equal to R1 R2 divided by R1 plus R2. Terminals of the cell are open. Now the potential difference across the terminal is equal to EMF because no current is drawn. Okay, ಇಲ್ಲಿ ಕರೆಂಟ್ ಅನ್ನ ಹೊರಗೆ ತಗೊಂಡು ನೋ ಕರೆಂಟ್ ಈಸ್ ಡ್ರಾನ್. ರೆಸಿಸ್ಟೆನ್ಸ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಏನಾಗುತ್ತೆ, ಕರೆಂಟ್ ಡ್ರಾ ಆಗುತ್ತೆ. ಟರ್ಮಿನಲ್ಸ್ ಆಫ್ ದಿ ಸೆಲ್ಸ್ ಆರ್ ಕನೆಕ್ಟೆಡ್ ಬೈ ಅ ವೈರ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆರ್. ನೌ ದಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಕ್ರಾಸ್ ದಿ ಟರ್ಮಿನಲ್ ಈಸ್ less than the EMF of the cell because the current is drawn by the resistor. Opposition offered by the cell to the flow of the current is called as internal resistance. Internal resistance of the cell can be measured by using potentiometer. Okay, you have the practical, no, that is potentiometer. Two cells of EMF E1 and E2 are connected in series so as to send the current in the same direction. Then equivalent EMF is nothing but ES is equal to E1 plus E2. Therefore the option is option A. The two cells of interresistance R1 and R2 are connected in series. Now interresistance of the combination is nothing but RS is equal to R1 plus R2. Two cells of EMF E1 into and interresistance R1 R2 are connected in parallel. Then the EMF is given by EP is equal to E1 R2 plus E2 R1 divided by R1 plus R2. The basic principle behind the Kirchhoff's first law, it signifies conservation of electric charge. Okay, first law ಏನು ಹೇಳುತ್ತೆ, sum of the current entering into junction is equal to sum of the current leaving junction. Therefore, it will have conservation of charge. The basic principle behind the conservation of Kirchhoff's second law is conservation of energy. Meter bridge is built on the principle of Wheatstone network. Okay, Wheatstone network ಮೇಲೆ ಬರ್ದಿರ್ತಾರೆ. So next question number 46. To measure the EMF of the cell, one may use potentiometer. Okay, if you use the potentiometer, it is a device which is used to measure EMF and the voltage more accurately. To measure the resistance of a wire, one may use meter bridge. Okay, you have the experiment. Meter bridge ನೀವು use ಮಾಡಬಹುದು. For measuring EMF of a cell, potentiometer is prefers to voltage because potentiometer draws no current. Okay, potentiometer current ಅನ್ನ draw ಮಾಡೋದಿಲ್ಲ. 49. Wheatstone bridge is better method to measure resistance of the wire because it is a null method. Okay, now Ig is equal to 0 ಅಂತ ಮಾಡ್ತೀವಲ್ಲ, therefore it is a null method. Last question. In a potentiometer circuit, EMF of an experimental wire is directly proportional to the balancing length. Okay, you have the relation in experiment E1 by E2 is equal to L1 by L2. That is, EMF is directly proportional to balancing length. Thank you. Please subscribe Southern Pathshala for more such videos.